This video, we're going to talk about 4.1 Objective 3, where we determine whether an outlier affects the mean or median. So let's go ahead and look at problem 1. The following table gives the total area in square miles, both land and water, of 7 states, complete parts A through C. Here's our table. So let's go into stat, edit, and let's put this data in here. Not the names, right? But 96,003, 55,875, 82,168, 68,994, 261,914, 6423, 43,566, and I know what's coming up, so I'm just going to come over to L2, and I'm going to copy L1, and I'm going to come over to L3, and I'm going to copy L1 because I'm going to need other copies of that list later. So now let's quit out of that, and I want to stat calc one variable statistics on L1, and it's going to give me the mean is 87849, and the median is 68994. And now we're asked to look for an outlier that's on the high end, and I'd say that that's definitely Texas is on the high end, that it's significantly larger than all the rest. So I'm going to come in here to my second list here, and I'm going to just delete that entry for Texas to ignore that outlier, and I'm going to recalculate my one variable statistics for L2 now, and that gives me a new mean of 58,838.2 and a new median of 62434.5. And then we're going to be asked to find the outlier that's on the low side in L3. And that's going to be Hawaii, which is 6,423. So I'm going to come here and I'm going to just delete that one. And that is now ready for me to calculate one variable statistics on L3. And I'm going to get a mean here of 101,420 and a median of 75581. My large one that I got rid of was Texas, and my small one that I got rid of was Hawaii. And I'm going to compare these numbers and say that relatively speaking, the mean was influenced much more by getting rid of outliers than our median was. We're adjusting our median slightly just because it adjusted the number of items in the list, and I'm going to a different item in the list, but it wasn't really a significant change compared to the change that we see in the mean. So that's what they wanted us to see, is that overall, roughly, the median isn't very affected by outliers, but the mean is. So cans of soda will vary slightly in weight given below. are the measured weights of 7 cans in pounds. Let's go ahead and enter this data in here. 0.8161, 0.8194, 0.8166, 0.8175, 0.7912, 0.8144, 0.8124. So let's find the mean and median. So stat calc one variable statistics on L1. Our mean is, and we're going to go to 5 decimal places, 0.81251, and the median is 0.8161. Now we're going to look for one that is significantly higher or lower. And I'm going to come here to stat, sort ascending, second L1. And going to come back in here and so I would have to say that nothing looks too far above or below, other than maybe that 0.7912 looks to be a little bit on the low side. So that's what they want us to say, is that that's significantly lower than all the other ones. So we're going to go ahead and take that out of the data set now, and we're going to run this calculation here again, where we find the mean and median. And now the new mean is going to be, again, to 5 decimal places, 81607. And the new median is 0.81635. And so see how much closer the mean and the median are now. We really like that when the mean and median are the same or really close to each other like that. We like when our measures of central tendency align like that, especially when the mean, median, and mode are all the same thing, because that's what we're looking for in something that we're going to call a normal distribution later. All right, that is it for this video, and we'll come back next time and talk about 4.1 Objective 4. See you for the next video.